distant past, around 66 million years ago, our planet experienced a catastrophic event that forever altered the course of life. This was the Cretaceous-Paleogene extinction, a colossal scale wiping out entire classes of species and transforming the face of the Earth as we knew it. What caused this dramatic upheaval remains a mystery, but there's no denying its profound impact. The majestic and terrifying dinosaurs, which once ruled the Earth, were replaced by a new reign of equally impressive creatures, mammals. During the Cretaceous-Paleogene extinction, a staggering 3/4 of all living organisms perished, including nearly all non-avian dinosaurs. This marked the end of the Mesozoic era and the beginning of the Cenozoic era, which continues to this day. The Cenozoic era is divided into 3 periods, each varying in climate and the diversity of the biosphere. The first and longest period is known as the Paleogene, which began roughly 66 million years ago and lasted for an astonishing 43 million years. During the initial 10 million years of this epoch, the Earth's biosphere struggled to recover from the devastating blow of the mass extinction. This period, known as the Paleocene, presented ample ecological niches left vacant by the extinction of numerous dinosaur and Cretaceous species, and nature responded swiftly, filling these gaps with a new group of dominators, mammals. Picture the geography of this prehistoric world, a familiar map, yet with a few subtle differences. North and South America were separated by tropical seas, while the Indian subcontinent was journeying towards the Asian shores. The ancient ocean known as the Tethys lay between Africa and Eurasia, gradually yielding to the movements of tectonic plates. The climate of the time was warm and stable, shrouding most of the planet in dense, lush, tropical forests. The abundance of vegetation allowed for the rapid propagation of smaller creatures, particularly the ancestors of today's diverse mammal predators. Among these thriving mammals were the Myiacids, agile and cunning predators resembling modern-day martens. They would later give rise to the rich array of mammalian predators we know today. Around the same time, Archaeocetes, the precursors of today's whales, were taking their first steps towards an aquatic lifestyle. Though not fully adapted to life in the sea, these early ancestors showed signs of change, with limbs and respiratory organs gradually evolving for prolonged underwater stays. The Earth's journey continued with the Eocene, spanning approximately 56 million years ago to a little over 22 million years ago. During this period, the continents began to take on more recognizable shapes. India finally arrived at the southern shores of Asia, and the collision of tectonic plates formed majestic mountain ranges, such as the Himalayas. One of the most fascinating creatures of the Eocene was Andrewsarchus, among the largest mammalian predators to ever roam the Earth. With a skull measuring up to 84 centimeters and a bite force surpassing that of any contemporary land predator, Andrewsarchus was an extraordinary marvel. Despite its massive size and predatory prowess, researchers discovered that Andrewsarchus belonged to the class of primitive ungulates, with its closest relatives being the ancient ancestors of today's hippos and cetaceans. Although much remains a mystery about this intriguing creature, evidence suggests it was an omnivore, perhaps even scavenging on carrion. As the Eocene gave way to the Oligocene, roughly 33.9 million years ago, the Earth experienced global cooling. Warm tropical forests gradually gave way to vast grasslands, and the Antarctic glaciation commenced, transforming the green continent of Antarctica into a frozen wasteland. This period also witnessed the violent eruption of the supervolcano, La Garita, which covered an enormous area with over 30,000 square meters of hot ash. Despite such cataclysmic events, life found a way to persist. Amidst this changing landscape, one group of creatures stood out: Indricotherium, the largest land mammals to ever exist. These colossal herbivores, related to rhinos, reached shoulder lengths of 4.8 meters, taller than even the largest African elephant. With their remarkable elongated necks, they could reach as high as 7 meters to graze on treetops. A mere human would scarcely be able to touch their knees, and today's rhinos could easily pass beneath their enormous bellies. With mass exceeding 20 tons, these behemoths were truly unparalleled in size. However, despite their dominance, the Oligocene saw the extinction of the Indricotherium, possibly due to competition from emerging large herbivores and shifts in the ecosystem. Alongside them, other fearsome predators like the entelodonts or bear dogs roamed the earth, resembling wild boars but equipped with powerful predatory instincts. These creatures were fast and fierce, posing a serious threat to the inhabitants of the time. The Neogene period followed, beginning around 23 million years ago and ending just 2.58 million years ago. This period brought the Earth closer to its present-day appearance, with continents assuming their familiar positions and many plants and animals resembling those we recognize today. However, this era was not without its unique inhabitants. In the deep seas, the mighty megalodon, a giant shark measuring up to 15 meters and weighing a staggering 35 tons, instilled terror among its prey. On land, gomphotheriums, relatives of modern-day elephants, wandered the earth, some of them boasting 4 solid tusks. Among the most intriguing creatures of this time was Gigantopithecus, a species of great human-like apes that lived around 1 million to 100,000 years ago. Standing at 3 to 4 meters tall and weighing over 500 kilograms, these colossal apes inhabited Asia and were related to today's orangutans. Gigantopithecus were too massive to climb trees like other human-like apes, but evidence suggests they made their homes in natural shelters, caves, and ravines. These giants likely had a varied diet, including bamboo and meat, and their relatively large brains hinted at a potential for primitive tool-making and intelligence. The Quaternary period, which continues to this day, saw the rise of Homo sapiens and the evolution of our modern ancestors. As humanity expanded its dominion over the planet, many of the extraordinary creatures that once roamed the earth became extinct. The Megatherium, a giant ground sloth, fell victim to primitive human tribes in South America, and Diprotodons, massive marsupials, vanished from the Australian landscape. Yet, some scientists propose an alternative theory regarding the extinction, suggesting that it may not have been solely caused by hunting. Instead, they point to an anomaly in the Earth's magnetic field, coupled with a local temperature decrease. These changes, along with fluctuations in radiation levels and cooling, resulted in slowed plant growth, leading to famine among the herbivores. In this view, the tragedy was inevitable, and human presence simply hastened its conclusion. The Holocene, the last phase of the Quaternary period, witnessed the rapid advancement of human civilization. Homo sapiens spread across the entire planet, asserting dominance over all other inhabitants of Earth. As we marvel at the achievements of our species, we must also confront the consequences of our progress. Industrial disasters and irreversible alterations to nature's balance stand as poignant reminders of the price we pay for our evolution. Perhaps one of the most pressing concerns is the worsening concentration of greenhouse gases in the Earth's atmosphere due to human activity. This global dilemma poses a significant threat to all living organisms, from the simplest bacteria to the most elaborate multicellular beings. Tragically, each passing year sees a decline in the number of captivating creatures that grace our planet. It is disheartening to realize that human folly, uncontrolled hunting, irresponsible land development, and indifference to the environment have contributed to what scientists now fear as a potential 6th mass extinction event, one that rivals the gravity of the previous 5. These pressing issues raise crucial questions about our future. Will humanity halt its destructive path before it leads to self-elimination? How long will it take our planet to recover from the consequences of technological progress? And in the face of such challenges, will nature find a way to produce radically new life forms that can weather this crisis, as it has done before? And if you've enjoyed this video, make sure to give it a thumbs up and subscribe to our channel. Thanks for watching.